Okay, today we're gonna continue talking about first moment of area part 2, and we're gonna talk about irregular shapes like the one shown here, you can see here, which is the parabola, and then we're gonna take a problem solving for in general, so as a application for the moment of area. Now, if you want to get the centroid for this shape, engineers found that it's the easier way to take a strip and then solve based on this strip, and then after that do the integration to find a centroid for the whole curve. Now the first step, let's do it together. The first step, we want to get what's k, sorry. If y equals to kx squared, which is written here, right? Then if we replace y and x, y by b, sorry, so replace them. So this is b equals to k, and x squared is a squared, and then we can find that k is b over a squared. Okay, then let's find the area for the whole curve. Area is equals to the integration with respect to dA. Now replacing dA with y dx, because we are now integrating with respect to dx, we're integrating y dx, so its area will be equals to the integration of y dx. And if you replace y with this, then we will have the following. It's equal to the integration y equal k is b over a squared, multiplied by x squared dx with respect to dx. This is the whole curve, so it's from 0 to a, right? And then this will give me, if you do this, it will be a equal b over a squared multiplied by x cubed over 3 with the interval from 0 to a. Now you know that we will replace x with 0, and then we'll replace it with a, we'll subtract them, a then 0, and then this will give me eventually a b over 3. Now we found the area, which is ab over 3 for the whole curve, this curve. Now using the vertical strip here, number 3, we want to find the first moment of area by performing a single integration. So qx, I called qx, which is the first moment of area with respect to x, equals to the integration x bar equals, so let's write it here, x bar el, okay, dA. Now doing the same thing, x bar is what is equals to x, and dA is y dx, and then to continue doing the same thing, it's from 0 to a, it will be x multiplied by b over a square x squared dx. And then this will give me the interval b over a squared x power 4 over 4, 0 to a, and then eventually it will be equals to a squared b over 4. Doing the same for y, because we have to find the centroid, we need x and y to coordinate, so it's integration of y, and y el is y over 2, so I'll write it first, y l bar dA. Replacing both, it will be y over 2 b over a squared x squared dx, right? And sorry, so we are yes, right. And then what we have to do, same thing, get the interval b squared over 2a power 4 x power 5 divided by 5, interval 0 to a, and this will give me ab squared over 10. Now we found first moment of area, we found the area for the whole curve. Now we need to move and find the area, we need to move and find the centroid. Okay, finding the centroid, let's do it. To find the centroid, we need to divide the area. We need to divide, sorry, the first moment of area. So number 4, first moment of area that we found. So x bar equals to the first moment of area divided by the area, summation of the area, or the area for the whole thing, and it is equals to, so a square b divided by 4 all over the area ab over 3. So this will give me 3 over 4a. So this is the centroid in the x direction, and then we do in the y direction, which is a, right? Again, same thing. I mean, we just replace it, ab square over 10 divided by ab over 3, and this will give me 3 over 10 or 0.3 b. So these two values will give me the centroid of the structure. If you're going back here, that means I have the centroid somewhere here. Somewhere here. When a is 3 over 4a, we have to move 3 over 4a. So move 3 over 4a, for example, this is 3 over 4a, and then go up. So this is the x direction, and then go up by 0.3 of b. So somewhere here. That's the centroid. Okay, let's take a quick application, which is if we have a beam. This is a regular shape. Again, this is what I explained, that if we have a regular shape, we need to find what is the equivalent load. And then with this equivalent load, we will find the A and B, or O and B reactions. And finding this is with the integration, as we said. We take a strip and then do the integration with with respect to the x. That's the same. That's what we said. But if you want to solve this, the first thing that we need to do here, we need to cut it into 2 sections. That's it here. So this is a triangle, and this is a rectangle. So let's call it 1 and 2. All right, 1, 2. And of course, if 2, then they will start from 0 to this number. So it's 4.5. Actually, it's 4.5. So if we want to get this number now, because we subtract both the triangle and rectangle, so it's 4.5, 4.5 kilonewton minus 1.5. So it's actually 3. This is 3 kilonewton. This is 0, and this is 1,000 or 1.5 kilonewton. Quickly saying, the first thing that we need to do is finding the area. This is the area, A1, A2. What's the area of the rectangle, which is here? It's 1.5 multiplied by 6, which is 9. And the area for the triangle, it's BH over 2. BH over 2. B is this from here to here, which is 3, multiplied by H over 2, which is 9. So area 1 and area 2 are equals to 9. Finding the x bar, so summation of area will be 18. It's important. So the equivalent load, guys, is 18. So we have now 18 kilonewton equivalent to these two loads, but we don't know where is it exactly. So we need to find the centroid. So x bar for the triangle, starting from here, half of this distance, which is 3. So our reference is here, reference, starting from here. So take half of the 6, which is 3, and from the previous video, we know that this is H over 3. H over 3 will give me the centroid of a triangle from here to here somewhere, right? H is this one, is this one, which is 6. 6 over 3 is 2. Now, but we have to refer it to the reference, right? So it's 2 from here, but it's 4 from the reference, because 2 minus, just 6 minus 2, guys. So it's somewhere here, right? Which is 4. So this will be 4, because you have to take everything from the reference. This is why I'm taking it 4, not 2. And then x bar area is 27, which is 3 times 9, and then 4 times 9, 36. If you do the math, it's equal to 63. Simply, centroid is what is the x bar a divided by summation of area, and this will give me 63 over 18 equals to 3.5 meters. So now that means, let me draw it here. That's the beam. Okay. The distance here is 6 meters from here to here. These two loads are equivalent to 18 kilonewton, which is the sum of areas, at a distance of 3.5 3.5 meters from point A. And then you can go and find the reactions as we saw in the previous lectures. Hope you enjoyed it. That's the end of this video, and we finished from talking about first moment of area and its applications.